My name is Aishwarya. I am from Triple E section. My roll number is 23401802338. Subject name is Chemistry. Today my topic is Principle and Applications of IR Spectroscopy. We discuss content. Introduction of IR Spectroscopy. Principle. Types of vibrations. Factors influencing vibrational frequency. Instrumentation. Applications of IR spectroscopy. Conclusion. Introduction of infrared spectroscopy. Infrared spectroscopy means IR spectroscopy is the measurement of the interaction of infrared radiation with matter by absorption, emission or reflection. It is used to study and identify chemical, substance or functional groups in solid, liquid or gaseous forms. It can be used to categorize new materials or identify and verify known and unknown samples. The method or technique of infrared spectroscopy is conducted with an instrument called an infrared spectrometer or spectrophotometer, which produces an infrared spectrum. An IR spectrum can be visualized in a graph of infrared light absorbance or transmittance on the vertical axis versus frequency. Wave number or wavelength on the horizontal axis. Typical units of wave number used in IR spectra are reciprocal centimeters with the symbol centimeters. Units of IR wavelength are commonly given in micrometers, formerly called microns. Symbol micrometers, which are related to the wave number in a reciprocal way. Principle of IR spectroscopy. First point, when the energy in the form of IR is applied and if the applied IR frequency is equals to natural frequency of vibration, that absorption of IR takes place and a peak is absorbed. Second point, molecules are excited to the higher energy state from the ground state when they absorb IR radiation. Third point, when a compound is exposed to IR radiation, it selectively absorbs the radiation, resulting in vibration of the molecules of the compound, giving rise to closely packed absorption bands, called as IR absorption spectrum. Principle of IR spectroscopy. The band corresponding to the characteristic functional groups and the bonds present in chemical substance. Thus, an IR spectrum of a compound is considered as the fingerprint for its chemical identification. First one is ultraviolet. Middle one is visible. Last one is infrared. Types of vibrations. Simple diatomic molecules have only one bond which may stretch. In polyatomic molecules, each atom having a 3 degrees of freedom in 3 directions which are perpendicular to each other. Thus, a molecule of n atoms has 3n degrees of freedom. For a linear molecule, 2 degrees of freedom describe rotation and 3 degrees describe translation. So the remaining 3n minus 5 are number of fundamental vibrations, while for a non-linear molecule, 3 degrees of freedom describe rotation and 3 degrees describe translation. So the remaining 3n minus 6 are number of fundamental vibrations. More complex molecules have more than one bonds and different types of vibration may occur. Vibration fall into the two main categories of stretching and bending. First one, stretching vibrations. In this type of vibrations, the bond length is increased or decreased at regular intervals. There are two types of stretching vibration, symmetrical stretching and asymmetrical stretching. First diagram, downward direction is symmetrical stretching. And next, second one, downward and upward direction is asymmetrical stretching. Second one is bending vibrations. In this type of vibrations, a change in bond angle occurs between bonds with a common atom, or there is a moment of a group of atoms with respect to the remainder of the molecule without movement of the atoms in the group with respect to one another. The bending vibrations are also called as deformation vibrations. Deformation vibrations are two types. First one is in plane bending vibration. Second one is out of plane bending vibration. These two diagrams of in plane bending vibration and out of plane bending vibrations. Factors in plane vibration frequency in ion. The value of absorption frequency is shifted if the force constant of a bond changes with its electronic structure. Frequency shifts also take place on working with the same substance in different states, like solids, liquids, and vapors. A substance usually absorbs at higher frequency in a vapor state as compared to liquid and solid states. Instrumentation. The instrumentation of infrared spectroscopy is illustrated below. First, a beam of IR light from the source is split into two and passed through the reference and the sample respectively. Now, both of these beams are reflected to pass through a splitter and then through a detector. Finally, the required reading is printed out after the processor displays all the data passed through the detector. Is the diagram of instrumentation of IR spectroscopy. Graph of the IR spectrum. Given below is a sample of typical infrared absorption frequencies. Applications of IR spectroscopy. Identification of functional groups and structural elucidation of organic compounds. Quantitative analysis of a number of organic compounds. Study of covalent bonds in molecules. Studying the progress of reactions. Detection of impurities in a compound. Ratio of cis-trans isomers in a mixture of compounds. Shape of symmetry of an inorganic molecules. Study the presence of water in a sample. Last one is conclusion. Infrared spectroscopy is a powerful analytical technique that has numerous applications in various fields. Its ability to provide detailed information about the composition and structure of materials makes it an essential tool for researchers and scientists. As technology continues to improve, it is likely that IR spectroscopy will become even more versatile and useful in the years to come. Thank you, sir.